Might be like, I have no idea what she's talking about. This is supposed to be a full moon show, and she just mentioned the globular cluster. So I'm actually gonna let's just start over. So, good evening, happy Sunday evening to those where in the world it still is. Perhaps it's Monday morning for you, and but for me right now it's Sunday evening. I am the last of tonight's full moon trilogy series. So this is the August full sturgeon moon, and earlier if you were listening, you heard Paul Cox with his Practical Astronomy live cast talking about the moon and different ways to image it and what you're looking at when you look through the telescopes. And then later, at about 2 hours ago, we heard Helen Avery, our Slooh storyteller, talking to us about the stories behind the full moon and the name of the sturgeon moon. And now I'm going to talk about some of the science behind the two things that Paul Cox and Helen Avery talked about a little bit more. We're going to talk about some surface features. We're going to talk about some gravity. We're going to talk about what's called lunar libration and why it happens. So if you're following along with me at slooh.com in the Space Situation Room, you'll see that underneath the video are telescope buttons. You can, instead of leaving away from the video page to look through the telescopes, you can click on those buttons and it'll switch for you right there. We also have the camera button on that page where you can take images of what you're looking at. And so if you're following along with me, you can see I'm actually looking at the telescopes with you. This is our Canary 4 telescope, and I am going to click the camera button and take an image. And now I have this image. So you can do the same thing if you're following along and you see any really cool moon pictures that you want to take. So let's get started again. What I was originally trying to talk about was lunar libration. So the common assumption when we talk about why we only see one side of the moon is that the moon doesn't rotate. But in fact, it's actually the opposite. The moon does rotate, and that's why we see only one face of the moon. Let's talk about that. So the only way for this to be possible is that the moon rotates once for every one orbit that it makes around the Earth. If you think about the Earth and the sun, the Earth rotates about itself on its rotation axis every 24 hours. The Earth orbits the sun every 365 days. So our year is significantly longer than our day, right? For the moon, it rotates about itself every 29 and a half days. It also orbits the Earth every 29 and a half days. So because those are equal, the moon is tidally locked to the Earth. You can demonstrate this with objects you might have in your home, like your hand or your phone or something. So if you pick up an object, whatever you have near you, in your, let's say I'm right-handed, so I'm just going to go with that. Feel free to use whatever hand you want. Hold your other hand in a fist. That's the Earth. The hand that has the object in it, the object is the moon. If you face, I'm using my iPhone, so I am facing my iPhone towards my fist. So I'm facing the moon towards the Earth. If I orbit my hand, my iPhone, around my fist without rotating the iPhone, do you see that the same side is not always facing the Earth? It changes. Now, if I rotate the iPhone as I orbit the iPhone. I swear this is not an ad for iPhone. Just when I said grab the object near you, that was what was sitting next to me. Then by rotating it as I orbit, I can keep the same side always facing the Earth. So let's watch a little video that helps to explain this. Here we go. This is what I'm talking about. The moon without any rotation. If we originally started by seeing that red face, we no longer see it now because, well, I can't hover over it, but because it's not orbiting, it's not rotating. Now, when it rotates, you'll see that the same side is always able to fit. Oh, Well, so first it's going through a rotation that is just much faster than its orbit. So we are again seeing all sides. So, right, as the video says, this is not actually what the moon does. Correct, right, because it doesn't rotate that quickly. Here we go. So when we sync up so that the moon rotates once for every orbit, then you see the same face of the moon all the time. That's called tidal locking. It's due to gravity. The moon and the earth pull on each other. They both have gravity. This pull distorts the shape of the moon and of the earth. The moon's pull on the earth causes some of Earth's ground to rise up about a foot in the direction of the moon. It also is why we have tides. The Earth's pull on the moon is much more significant because the Earth is relatively much larger in mass, and it distorts the shape of the moon even more. It creates what we call tidal bulges, which shift the rocky mass of the moon toward the Earth and kind of act like love handles for the Earth to grab onto. The Earth's gravity, the more it pulls the mass of the moon towards the Earth, kind of in an oblique shape, and then that allows for the Earth to lock onto it even more. Over time, this tidal bulge phenomenon has slowed the moon's rotational speed until it came to rest with one side facing the Earth because it slowed its rotation down until it matched its orbit. This is actually the case for all large moons in our solar system. So this is not something that's unique to the Earth moon system. Io, Ganymede, Titan, Charon, all these large moons are tidally locked to their planet. And if you've tuned in before to some of my live casts about habitability around other stars, we've discussed this tidal locking issue and what it can do to habitability, because a planet can also be tidally locked to its star if the situation is right. So the moon's gravity tugs on the Earth just enough to moderate Earth's wobble, because we rotate around our axis, but we also wobble a little bit. And this helps to provide us a stable climate. And like I mentioned, the tides of the oceans that we're familiar with. The surface gravity on the moon is just 1/6 of the surface gravity on Earth. Much, much less. That's why you can jump much higher on the moon. So even though we seem to only see one face of the moon, that's what I just said to you, we do actually see a small portion of the other side of the moon. Now this other side is commonly referred to as the dark side of the moon, and let's think about why that is not the correct terminology for it. And the correct way to talk about it is the far side of the moon. The side not nearer to where we are as the observers, the other side, the side we don't see. But it is not dark. And if we re-watch some of this video, we can see why it's not dark. Sunlight, if you pretend the sun is off to one side, will hit that other side of the moon. That's what's happening in a new moon. In fact, the other side of the moon is lit up. So it is not the dark side, it's just the far side. So this small portion of the far side that we do actually get to see, this is because of what we call lunar libration. So this happens in two directions. There's east-west libration, and then there's north-south libration. The east-west libration occurs because the moon's orbit is slightly oval-shaped. It has an eccentricity. It's an elliptical orbit. It basically means the moon moves faster in its orbit when it's near Earth and slower when it's further away. This is due to the effect of gravity. As the moon is closer to the Earth pulls on it and the moon moves faster. When it's further away, it has less of an effect, this gravitational pull from the Earth. So as the moon orbits the Earth, because of this speed increase and decrease, it appears to have like a slight side-to-side rocking motion as we view it, so that we can see a little bit beyond the east and west side. Now there's also north-south libration. It's another type where this is actually caused because the moon is on a slight 5-degree tilt of its orbit with respect to Earth's orbit around the sun. So if you look at our orbit around the sun and call that a plane, the moon's orbit around the Earth is at a 5-degree tilt to the Earth's orbit around the sun, to that plane. So this means that sometimes the moon passes below Earth's orbital plane and sometimes above, which gives us a vantage point a little further north and a little further south. Another but much smaller factor to consider is your location on Earth. If you live at a high northern altitude, you can see a little further north on the lunar surface. Similarly, if you live at a high southern latitude, you can see a little further south on the moon's surface. All in all, when we talk about lunar libration, the face of the moon that we see, we actually get to see more than 50%. We get to see about 59% of the moon's surface from Earth. So let's look. Here is a nice time lapse of lunar libration. So if you're watching this, you can kind of see the east-west rocking and the north-south rocking. One point to focus on to help kind of hone in on what we're seeing is the Tycho crater down here at the bottom. It's that bright white spot with like a little ring in the center. This is the Tycho crater. And if you watch that, you'll notice how you can see a little bit further south sometimes as it rocks around. So here, oh goodness, I didn't show you that. Now you can see it. There we go. See Tycho craters peeking in and out. And just for reference on the tidal locking video, let's replay it. So if the moon does not rotate at all, but orbits the Earth, this is what happens. We will see all sides of the moon. If we fast forward a bit, if the moon rotates super, super fast as it orbits the Earth, we will again see all sides of the moon very often. If the moon only rotates once per orbit, we see the same side. But instead of just seeing 50%, we actually see that 59% because of this phenomenon known as lunar libration. So as I mentioned to focus on the Tycho crater, here's a good image showing the Tycho crater and how much extra we can see below it based on lunar libration. So this is something that would be fun for you to do with our telescopes and try to image the moon at different times and see if you can find some of this lunar libration happening where you can see some extra portions. Another way it might look, if you look at this image up here, we have the two halves of the moon, but if you notice, you're seeing more than 50% on each side. And so this crater line here, this ridge up towards the top, would overlap with the crater ridge line on the right-hand side, and you're noticing that you are seeing more than 50% of the moon. So I want to put the challenge out there, if Paul Cox didn't do it already, because I'm sure he did, but if he didn't, I want to put the challenge out there for you to try to catch lunar libration yourself. So I'm just back going through our telescopes just to see what's up, what we're looking at. We have some globular clusters, we have a nebula, we have the full moon, and I wonder what's on the Chile telescope because I know there's some moon missions there. Yes, look at that, beautiful. There's a Tycho crater down at the bottom. Snap your pictures. Okay. Something else I wanted to talk about is moonshine. Not the beverage, but the actual light that comes off of the moon. So moonshine, the light that we see when we look at the moon, is not the moon putting off its own light. It's not a ball of fire like the sun, like a star. It's actually reflected light from the sun bouncing off the surface of the moon. So just like a quick little infographic for you, if you're wondering what I'm talking about. Sunlight hits the surface of the moon and bounces off. It's reflected as if it were like a flashlight and shines back towards Earth. When astronauts were walking on the surface of the moon, they reported that it was a dark gray, the color of asphalt, pretty much. This dark color and the bumpy surface of the moon, it's very rocky and dusty, has a really low reflectivity. It's about 12% of the light that hits the moon gets reflected. Additionally, the amount of light that we get from the moon depends on the point of its orbit. So during a full moon, it's so bright, it obscures fainter objects in the night sky. One question that we had earlier today on Twitter was, how come we don't have any Mars missions available right now? Mars is visible with the naked eye if you go outside. Well, with telescopes, it's a little bit different. Our eyes, yes, they're lenses, but they behave differently than the lenses in our telescopes. And Mars is actually really close to the moon right now. So our telescopes would be oversaturated with this bright light from the full moon, and you wouldn't be able to see Mars. So it'll come back on in a few days, but this is because the moonlight is so bright. Even though the reflectiveness of the moon is only 12% of the light that hits it is reflected, it is still, the sunlight that's hitting it is so bright and so intense that just 12% is a lot. And so if you go outside and look at the full moon, you might have been able to see before, or maybe you can tonight, but the moon can actually cast shadows. It is enough light that you might be able to see your shadow. If you're in a very dark area with a really bright full moon, look and see if you can see your shadow. So during a full moon, like I said, it can obscure fainter objects because it's so bright. A lot of things can't be observed through telescopes during this time. Moonlight gets in the way. Sometimes if you see a bluish tint through our telescopes, I'll actually bring that up for you right now. I believe there was one of them that's doing that, where it's a little bit of a bluer hue. Here we go. This is moonlight. Usually. I won't say it's always the blue color is moonlight, but usually it's moonlight. The brightness during the daytime, when the sunlight is hitting the surface of the Earth where you are when it's during the day, usually completely washes out the light from the moon and washes out the light from the stars for sure. But sometimes we can see the moon during the day when the sun is shining on the surface and it's high enough in the sky. If you actually, where I live in New Jersey, the past few days leading up to this full moon, we've seen the full moon during the day through the bright blue sky. I mean, it was lit up so much from the sunlight. The moon follows an elliptical orbit around the Earth. Like I said, it's not a perfect circular orbit. So it changes its distance from the Earth, the average distance, quite a bit. And when it's at its closest point and it's full, this is known as a supermoon. When it's at its furthest point from the Earth and it's full, we call it a mini-moon. The supermoon can be about 20% brighter than normal. So if you really want to see your shadow by moonshine, you should go outside during a supermoon. The same phenomenon happens in reverse, in fact. If you observe the Earth from a spot on the moon, you can see Earthshine. So the sunlight will reflect off of the surface of the Earth as well. And this, in fact, is how we see sometimes exoplanets and exomoons. Well, not exomoons, but moons in our solar system and exoplanets, because if they reflect the light from the sun, from their host star, we will be able to see it reflecting back to us. not least, when we look at the surface of the moon, especially in this close-up right here, look at the variance in the color. We have really, really dark patches and really, really light ones. And you might be wondering what exactly we're looking at. Notice the light is reflecting off. I mentioned that the moon is rocky and dusty. It's bumpy. It's not a smooth texture. So the light there's shadows cast on the moon from the sunlight. It reflects off of different points differently. And so some areas are brighter and some areas are darker. The surface of the moon is heavily cratered. The dark patches are called lunar maria. These are lower lying regions. They're covered in old magma, like old iron heavy lava flow from about 4 billion years ago. When the moon was forming, and in its early formation, it had a really very violent volcanic history. And this lava flow settled onto the lower lying regions of the moon that were heavily cratered, while the bright areas on the moon were too high in elevation to be covered by this ancient lava flow. So they're called the lunar highlands. So if we're looking at this, the Canary 4, the Canary Solar System telescope right now, we're looking at a close-up of the moon's surface. The dark patches on the right-hand side of the feed are lunar lowlands, the lunar maria. So these are these iron-rich areas where the reflectivity is very low, and also where shadows are cast. The lunar highlands you can see in the brighter regions down towards the bottom, but you can also see specific rings, which are these highland areas, they're kind of like the tops of the craters, like ridges, like mountain ridges. These actually represent the oldest parts of the moon's surface because they were never covered by the lava flow that occurred after the moon formed. So the moon forms, it gets bombarded with other space rock that's flying around, and then the volcanic activity happens and the lava covers some of these lower regions. So those lower regions have been more recently resurfaced, whereas the higher regions, like the ridges, are more, they're older. They're not as fresh, I guess you could say. So we're just coming back into view again on the Canary 4. A new mission started. Let's see if any other of our Canary scopes have it going. I think the Chile telescope still has the moon. Oh no, we're on a globular cluster right now. We'll be back on a full moon shortly. But if you are, you're looking around the telescopes and you're like, okay, Chile, Canary Islands, like, what time is it there? What's the sky look like? If you scroll all the way to the bottom, you can look at our all sky cam. And then you can see stars in the cam too. And this is not the sun. This is the moon. It looks super, super bright here, but that's because we have a really bright full moon. We can see this in our dome cam as well, and our horizon cam, that it is in fact nighttime. You can see stars out there. So let's go to our Canary Islands one and see. Here's our Tatey Peak webcam. Same thing. Here's our all sky cam. That's not the sun, even though it looks like it could be. It's a very bright full moon. So anyway, getting myself distracted here. So surface features of the moon. If you were listening to Helen Avery's live cast at 8 o'clock, you would have heard her talking about patterns or shapes in the moon. These are called lunar pareidolia. I'm not positive I said that right, pareidolia, but these patterns that humans see on the uneven surface when we're looking at, I want to see my surface so that I can point out how we might be able to see some shapes. This isn't great because it's super close up, so I'm just going to go to my pictures and show, one of the full moon. This was from tonight. This was from Chile. Here we go. So the way that we look in the sky and see conglomerations of stars and make constellation shapes out of them is a similar thing that happens when we look at the surface of the moon and we make shapes out of the surface features that we see. So there's also another term that I want to introduce. It's called the Terminator Line. I love that one. It's the light and the dark side of the moon. It's the line in between them. So when you have a phase, which we're not going to see tonight, of course, because we are looking at a full moon, but when you have a phase of a moon, the line that separates the dark and the light is the Terminator Line. I'm going back a little bit. So these are images of the moon. This is not a phase, in fact. This is from the lunar eclipse, the total lunar eclipse that just happened a few weeks ago. So if you were following along then, you might have some of these for your own, but if not, I'm giving you a glimpse of what we looked at when we watched that total lunar eclipse. So don't mistake this for a phase, but a phase coming from the orbit of the moon around the Earth. I mean, this is from the light of the moon being completely blocked out during the total lunar eclipse as the Earth moved in between the sun and the moon. But that line where it's dark to light, that's called the Terminator Line. I just find that really entertaining. Our chilly one, yep, we should be coming back on with the full moon. There we go. We really have spectacular views tonight of the moon. I mean, I don't know if I've seen such detail in the craters before. Let's zoom in and scroll over a little bit. Look at this, these craters. It's really very detailed. And so this would be the type of image where you could take multiple from the Chile 1 telescope over the course of time and see, you know, next month's full moon, the next month's full moon, start to take images and see how far you can view east to west and north to south, and if you can catch any lunar libration for yourself. Before I forget, I did have an image I wanted to share with you. This is an image of what I was talking about earlier, Earthshine. So when I said, you know, what we see from the moon is reflected light, it's moonshine. It's basically the sunlight is reflecting off of the moon's surface. Well, the Earth, I said, does the same thing. It reflects the sunlight. And so if you were standing on the moon, you might see Earthshine coming off of the Earth. But we can see Earthshine from Earth. So what you're looking at here, that bright crescent down at the bottom, that is sunlight hitting the moon and reflecting back towards Earth. It is a very thin crescent phase of the moon. The rest of the moon being illuminated is actually due to Earthshine. So the sunlight hits the Earth, reflects onto the moon, and then the moon reflects it back to us again. So we are seeing our own Earthshine when we see something like this. And so you can see this sometimes at night if we have like a particular kind, I mean, it really any phase, but we need some, you know, heavy sunlight reflecting off the Earth at the time. But I encourage you to go out and try to catch this one time during one of the phases, not during the full moon, obviously, but during one of the partial phases, and send in your pictures if you catch any of the Earthshine. I'd love to see them. So I'm going to leave you for the evening with these fantastic views. If you are tuning in, I'll be up for a while, so feel free to tweet me. Tweet us at Slooh. Tell us your moon stories. Ask some questions. Share your moon photos if you take them, you know, through our telescopes, or if you want to go outside and take your own full moon photo with that iPhone camera. And send them to us and share them with me and keep me company tonight. So that's all I have for you right now. In the next coming weeks, we have some special things coming up. Every week, you can catch Practical Astronomy with Paul Cox and Constellation Stories with Helen Avery. In the next few weeks, we have Comet 21P, which is the comet that's responsible for the Draconid's meteor shower that happens in October. The comet is whizzing by on its close approach to the sun on September 10th. So we're going to cover that live on Monday, September 3rd. So for all of you United Staters, join us to round out the end of your Labor Day, if you're like me, before you have to go, you get that freebie day off of work, depending on your profession. Then you've got to go back on Tuesday. But we'll be with you that evening watching the comet whiz by. And then we're going to keep tracking it for that week. So we are doing this a week before close approach. That way we can get prepped so we can track it over the week and watch it every day as it whizzes by Earth. And then towards the end of September, on Saturday, September 22nd, we'll be celebrating the September equinox with you. So tune in to find out what an equinox is, why it's different from a solstice. During the day, we'll have our solar telescope online, and then at night, we'll just look at amazing live views of the sky. Join us for all of these things coming up. And like I said, tweet us your photos, tweet us your questions. We want to hear from you. We would love to discuss your questions on air like this. And so even if we don't have a current show going on, tweet us in between them. Tweet us what you want to know coming up, and we'll feature them and we'll talk to you live. So I will see you all soon on Monday, September 3rd for the Comet 21P close approach. Happy moon viewing.